Hello everyone, this is Abdul Kas from the Midas Initiative. Today I'm going to show you how to convert decimal fraction from base 10 to other bases. Now let's say you are given a number like 29.125 and you are told to convert it maybe to an octal numbers. An octal means base 8. Or maybe they ask for bisimal. Bisimal is base 2, just like you have decimal in base 10. So it's good for you to understand the name of these different bases. Now we're given 29.125 base 10, of course. We're to convert it to either the octal numbers or the bisimal numbers or the quaternary numbers. So let's just do the octal, to base 8. Now remember that this is a decimal fraction. We have 29 point something. So what you have to do is you have to convert. But then how do we convert the one before the fraction? You already know how to convert base 10 to base 8. Remember the long division. So what you do is you just have 8 into 29. It can go into 29 3 times, actually, remainder 5. 8 can go into 3 0 times. Remainder 3. So if we count it from down up, we have 3 5 base 8 this time around because we're converting to base 8. But now we are going to the other side, which is the side after the decimal point. Now after the decimal point, you're going to do a different kind of calculation, which is actually multiplication. And this is how it goes. You draw a line. All right, now you have the 125, which is the number after the decimal point. Now remember, we're converting to base 8, so you're going to multiply by 8. So 8 times 5 is going to give us 40, but we can't write 40, so we write 0 carry 4. All right, so we keep the 4, and then we have 8 times 2, which is going to give us 16, plus that 4 that we carried will now become 20. Now we can't write 20, we write 0 carry 2. Now 8 times 1 is 8, plus that 2, making 10. Now we can't write 10, we write 0 carry 1, but because we have the overflow, that 1 will now enter the overflow. So we have 1 in the overflow. Now the moment you get to a point where you have 0 0 0 in this side, you don't need to start multiplying again, because if you multiply it will keep on giving you 0 0, so there's no point. It means you have gotten to the end of it. But there's something that I want to say before I get into the answer. Let's assume for one reason or another we don't have 0 0 0. It means you have to keep multiplying. Now if you multiply, it can get as long as it can sometimes, because you may not get to the place where you have 0 0 0 outside, and that is the only point that you stop. So most times they can ask you to put your answer in a particular decimal number. And if they tell you to put your distance in certain decimal places, what it means is that they need the fraction to be in a certain number. So if you keep on multiplying and it is getting down, and you get to the number of the decimal that they want you to present your answer as, then you can stop. There's no point going continuously to the fraction. And I'll explain as we go along. Remember also that the answer that you're going to give after the decimal point is going to be the one in the overflow, not the one outside it. And then we have 35 here, so it's going to be 35.1 base 8. So that is how to convert 29.125 base 10 to base 8. It's going to give you 35.1 base 8. But now let's say you want to do the bisimal. All right, the same thing, you want to now convert to the bisimal. Remember, we're going to use 2 this time around, so same process. 2 into 29 is going to be 14, remainder 1. Then 2 into 14 is going to be 7 times, remainder 0. 2 into 7 is going to be 3 times, remainder 1. 2 into 3, 1, remainder 1. And then 2 into 1 is 0 times, remainder 1. So what we have there is 1 1 1 0 1. Point. Now we have to do the calculation for the place after the decimal. Remember, that one is the multiplication, and we're going to multiply by 2. So we draw our lines and we say, okay, 2 times 5 is going to give us 10. We write 0, carry 1. 2 times 2 is going to give us 4, plus that 1 that we carried, 5. So we have 5. Then 2 times 1 is going to give us 2. So we have 2, 5, 0. We have to still multiply again. So we multiply again by 2. 2 times 0 is going to give us 0. 2 times 5 is going to give us 10. We write 0, carry 1. 2 times 2 is going to give us 4, plus that 1 that we carried, 5. So we have 5, 0, 0. We have to also still times again by 2. So in this case, we have to also times again by 2. 2 times 0 is going to give us 0. 2 times 0 is going to give us 0. 2 times 5 is going to give us 10. So we're going to write 0. That 1 will go to the overflow. That is it, because there is no any other number. The number has to be the number of the fraction at this point. And then so this one has to go to the overflow. So now we have 0, 0, 0 in the other side, which means we cannot do any multiplication again. So what we have in the overflow is 0, 0, 1. We're going to count it from top to the bottom. So it means what we're having is 11101.001 base 2. So it's the same. You just convert the 1 before the decimal point, and then you multiply the 1 after the decimal point. And remember, it is the numbers in the overflow that you're going to count from top to bottom, while in the long division, you already know that in the previous classes, you count from bottom to up. And then you have your answer in base 2. So that is it basically. So I want you to calculate the one for the quaternary, which is the base 4, and drop your answer in the comment section. I believe that with this and the previous class that we did, you'll be able to convert decimal fractions from base 10 to other bases, and from other bases to base 10. Remember that to convert to base 10, you have to do the expansion method, all right? For the ones before the decimal, for the ones after decimal, you have to still do the expansion method, but remember that you rank them -1, -2, and all of that, and then you do your normal simplification. I hope this is clear enough. Thank you very much for watching, and bye for now.